Hello, we'll get going in just a bit after I confirm everything is going as planned. Looks like we're live on Restream. And this here. Hi, DCD. Thanks for joining. Thanks for letting me know it's working. Hi, Mark. Hi, Beata. All right, I've shuffled my windows around. I realized like 30 minutes ago, I was like, oh, I meant to finish putting things there. So yeah, I think we're going. So hello, everybody. My name is Scott. I work for Adafruit on CircuitPython. CircuitPython is a version of Python designed for tiny computers called microcontrollers. Let me find a board. Here's a clue. So this is a microcontroller development board that Adafruit made. Here's the example. And on its back, it's got over here. Under this piece of metal, there's a little tiny chip that is an all-in-one computer. You plug in your device and it shows up as a CircuitPy drive. You're able to program CircuitPython right on this little thing. It's got sensors, it's got a screen and some buttons and some touch pads and stuff so that you can interface it with other things. So this is an example of what Adafruit makes. You can go to adafruit.com to purchase cool things like that. And I work on the software side, so I work remotely. Hello, Hams Labs. I don't know if I said hi to you. I work remote out of Seattle here, and I work on CircuitPython. So CircuitPython is one option that you have for programming these little tiny computers called microcontrollers. And so this is a deep dive, usually where I just talk about whatever I've been working on for CircuitPython. And this week it's actually tangential or like around CircuitPython, but not CircuitPython itself. And it's just, this week is blown by. So as I've talked about kind of throughout the whole year, like the way that I've been working as a software engineer has changed a lot. And it's changed in a way that I'm relying on large language models to generate a lot of the code and change the code for me instead of doing a lot of the typing myself. And what I found is that I get to this point where I have all this code, but I have not tested it. And testing it on device is always really revealing about whether like it actually works. And so I've had this idea to like actually do hardware in the loop testing, as I call it, which is, you know, you generate some CircuitPython code, you load it onto a device and actually verify that it works on the device. And that used to be something that was a nice to have. I did it within the like first few months of being on CircuitPython. We called it Rosie. So we had like this Rosie CI thing that like, I had a Raspberry Pi with like a bunch of boards all hanging off of it. But it like relied on the UF2 bootloader to be able to function. And then like, even then, like the Linux kernel at the time, which was like in 2017 maybe, like really early on in working on CircuitPython for Adafruit. Like I started in August of 2016. But I knew that like it was going to be critical, and it's like totally a best practice. And this is an example of where how large language models have really said like, no, like these things that were nice to haves for like doing proper software engineering, and like they're way more beneficial now than they were before. In addition to that, they also are like more valuable as well, because now they have more things using it, right? So like, not only is it testing the code that I'm doing, but it could also be used to test LLM generated code. Like we could do like pin muxing stuff, and like writing tests is way easier now because like you don't have to type it all in. You just say like, make me a test that does this. So part of that experience led me to the belief that I can't really rely on the host OS's Linux, or the host OS's USB stack to be stable over time. Not its fault, but like they like to make some assumptions about like the USB devices being compliant. And that's not always true when you're changing USB code. So I've had this idea for a little while. I think it kind of sparked with the native simulator. The Zephyr native simulator, which I've talked about before, is definitely a part of that because you can do it you can do it on your host device. But it has support for doing USB IP, and so I like started to learn more about what USB IP is. It is the ability to like connect to a USB device remotely over a TCP/IP connection or a TCP/IP server, and it's a Linux thing. So in Linux, you can actually like have two Linuxes where on one you say like, hey, like you detach this thing and serve it over the network, so like a keyboard or a mouse. And then you can go to the other Linux and say, hey, like attach to this USB device that's being exported by this other Linux server. So you can use it for like using mouse and keyboard on a remote server in the cloud or something. It's also really commonly used for bridging containers. So like your host computer has your mouse and keyboard or a test device, and you got to get it inside a container, and containers are good at doing like networky sandboxing and things. Hi, ISILTech34. And so it's been like kind of somewhat popular for that. And I was thinking, what would be really cool is if we had a standalone device. I've been using, let's see if the overhead works because I've got it. Hey, it works. Or at least it took a picture at one point. Yep, it's live. So what I've got here is it's actually off screen. And I showed this on Show and Tell too, but these are M5 stack boards. They're ESP32P4s. And this Ethernet jack has PoE, power over Ethernet. So I've got one plug into this device, and it's then plugged into a hub, and the hub is plugged into a C6. I think it's a C6. But you can see that I've got both things here. So what I've been working on this week is both the firmware for the kind of like the network bridge device, and then getting it to work kind of end to end with the serial stuff. So nowhere in this stack is my Linux operating system. Let's go to the desktop and see if I can make something work. So I've added this command called lsusbip, and it's doing MDNS discovery, and it didn't work. Let's give it another try. And if that doesn't work, I'll unplug it and replug it back in. It should work. I haven't actually been using this today, but the idea is that I can use these P4 boards to like kind of be isolated hardware setups for each individual like setup. So like one for a C6, one for a C3, one for a C2, one for an S2, one for an S3, and like figure out how to do like these very self-contained like hardware test setups. So that if I like have this IDF6 changes that I like really just need to test everything, I could just have one of each. I say build for these 6 things that are like a variety of things, and then run these tests on them in these like test harnesses, remote test harnesses, is my goal. And like, yeah, I've spent all week on it, but it's like once we get it set up, like it's going to be really nice. Let me catch up with the chat here and see what Mark said. So Mark said, on a non-electronics project, I've really gotten into LLMs to help me in the last few months. Saving typing is a great way to put it, and saving Googling time. Yeah, I think I've started to do more research through that too. DCD, that is correct. That's what I showed, the unit PoE P4. Ham's Lab has been doing hardware in the loop stuff using FruitJam, and the RP 2350 is really suited for that. Agreed. I really wanted to do Ethernet or Wi-Fi, And one of the things I ran into that makes me lean even more P4 is that the P4 has 16 host pipes, so it can talk to 16 endpoints at the same, like kind of concurrently. And that might actually be why it's crashing. Because I did do some I told Claude to do some refactoring yesterday, and I thought it was working, but maybe not. I wonder if I plug it in. We can see the debugging. So I can still plug it into USB, the host P4 device, plug it into USB and get debug output for that firmware as well. And then I actually have it connected to a second P4 that I'm starting to think about, okay, like one of the things I had to test and that kind of triggered this, like, oh, I don't want to have to do this, like, is protomatter. So protomatter is the code that generates pin sequences to flash images on RGB matrix, LED matrices. And that's the sort of thing where actually we don't need the matrix. If we had just a logic capture of that output, we'd know whether it was working or not. Or like we could write code that verified that it worked. And basically like you could have it like draw what the image actually was showing. Like you can, it's much quicker to do that sort of harness stuff now with an LLM. And so it's just awesome. So, so yeah, that's kind of like what I'm trying to get to is like, can I get some test harnesses up to help me with the IDF6 evaluation? And once I do that, I can like always use it, right? Like once I have it going, I can always use it. So, and then I mentioned this to Lady Ada, whose name is Lamore, on Monday, and she, I think, got convinced more of the value of this USB to IP bridge, particularly because she was like, oh, but like on Windows, there's only this like one way of like mounting them into Windows. I was like, well, no. Like I actually want to do the Python side too, so that like in Python you do all the USB stuff, so that you don't have to have your kernel involved at all. It's just Python that does USB class stuff straight into a TCP socket. And actually, let me just show you. Let's see if this works. Nope. Let me unplug the other one so it finds the right one. Let's just take a quick peek and see. I'm curious why it's not working. I actually have a mailbag as well. Let's reset it and see what it says. There's no reset button on it. Okay, so it's printing out port stuff. I found a couple bugs. It looks like the USB is failing. You know, I changed hubs and I wonder if the hub is bad. I bought a cheap hub off Amazon and it's possible it's not working. Which is why I only bought one of them. All right, well, I'm not gonna worry about it. I've got too much other stuff to talk about. Because I think people like mailbags too. So I'll do a mailbag here shortly. But yeah, so that's the idea. And then let me just show you here. So if you go to Adafruit GitHub, 2 of the 3 repos are up. Now this is like me clodding up. I'm not ashamed of that, but I have been testing it, like plugging things in and trying to do stuff. So there's this new thing here, and I'm just trying this Chrome. Like Chrome just released vertical tabs. I don't need that right now. So there's this new repo, Adafruit esp-uspip-bridge. So this is based on just an IDF project. It does actually require fixes in esp-usb. So if you look back here, you'll see that we have a forked version of esp-usb. That has, it must have a different branch. Oh, one thing I ran into is that the P4 host code doesn't support full-speed devices behind a high-speed hub. It is a high-speed controller on the P4, But if you put like another CircuitPython device on the other side of a high-speed hub, the thing talking to the high-speed hub has to do like all this split transaction stuff for carrying like full-speed transactions over a high-speed link, and that's kind of a pain. So I finally realized that I could just put that. They call it the high-speed OTG, but you can force it into a full-speed mode. And then you're talking full speed to the hub and then full speed to the devices too. So that's one thing I did here. And then the other thing was like if I unplugged it, or no, I was trying to get the ESP IDF. So one thing I'm trying to do is get like the IDF.py and ESP tool working over USBIP. And when you do those tricks to get into the bootloader, like you have to re-enumerate the device. So it like very briefly disappears and comes back up. And so there's a fix here to make it so that the hub controller on the P4 still recognizes when things go away for just briefly. So that's part of it. And then the other part, so that's the bottom layer that's on the device. And then on the host side, the way that I'm structuring it is that this here is a library that allows you to use PyUSB with a device that's available over USBIP. And so PyUSB is kind of like the low-level way of talking to USB devices from Python. It's also the API that we mimic in CircuitPython. So this is part of it. So building on top of this layer that has like the PyUSB boundary means ideally that like our class level drivers, so like serial drivers, mass storage driver code that's all in Python, will be ideally portable between CPython on a host using this bridge to USBIP and portable to CircuitPython itself. So that's one of my goals there. So yeah. That's what I've been thinking about. I just tickled Claude to try to do another P4 thing where it does logic capture so that like I don't have to have an RGB matrix. I just logic capture to make sure that all the patterns are still right. So I started working on that. And my idea is that you could probably integrate that into the same device that's doing the USBIP bridge. Taya says, can you go into more detail or repeat what you said about being patched for the USB IP brief device disconnect events a minute ago? Sure. So when you go from like application mode to bootloader mode on an ESP, there's this like quick toggle of things that happen to cause it to do the reset. And the way that USB hubs work, they don't do enumeration, but they have to convey back to the root hub, like the ESP in this P4 in this case, that like a device disappeared and came back, so that like the root hub can do the enumeration again. And the way that it does that is that there's kind of 2 bit fields, I think it is, on USB hub. One says like, is there a device on each port of the hub? And then also, did the port status change since you last read the status of the port? And so what was happening with the ESP hub stuff was that in order to detect a disconnect, it would say like, oh, was it there and not there? And if it was there and not there, then we'll do this process to like tear down what we thought was on that port and re-enumerate it. Or but it wasn't doing the case where like, if the device left and came back in between those 2 checks of that status, there's this other bit that says like, oh, by the way, it changed. And so you can check that too. And so even if before and after are say, yeah, there's a device, there's a third thing that says like, oh, by the way, the status changed between the 2 times that you read me. So you could know that like, even though it's both here and here, you know in between that it was gone. And that's important because USB devices, when they come onto the network, they have a default address of 0. and that means it needs enumeration, and the root hub has to tell it what address to use. So what was happening for me was that like I was doing requests to this device, and I was managing to tickle it so it disappeared. But because it disappeared without triggering a re-enumeration, I was trying to talk to a particular device address that was gone, and the other device didn't have a new address. So hopefully that's a little clearer. And it's an example in my mind of like, the only reason I got Claude there is because I've had experience doing USB. So yeah, the main goal of this P4 thing is to act as a bridge between USB land and a TCP/IP connection. However, the way that I think I can make it more of an all-in-one testing device is to also expose virtual USB devices. So in this case where I said like, oh, I just kicked off this thing to be a logic analyzer, I think the way that I'll bridge it upwards is like, I will pretend there's another USB device plugged in for this logic analyzer code, but it actually runs in the same CPU or like same microcontroller. But that's my theory. I don't have that working yet, but it's kind of this idea that like I can use a hub to plug a bunch of stuff in on the hardware test side, and then like as I realize what I need exactly, I can integrate it back into the same thing to cost it down. Ty says, that's cool, thank you. Does that mean that 2 could arrive at address 0 if both needing re-enumeration? So I think the way that you get around that is that like the root hub has some control over the status of hub ports. So like the root hub only has one device connected to it, right? So if there's one thing plugged into it, you know that like the only one device has device 0. And then there's a process for like, okay, now you have hubs, and like hubs are actually something that you talk to. And I think because you can talk to it, you can say like, oh, this port and this port now have devices on them, but like I'm not ready to talk to this one. Let me talk to this one first. I think it's the way that it would happen. The hub has some control over that. It's not like they're all on the same connected wires. I believe that's the way it works. And yeah, my brain is kind of dreaming a little bit about making a custom P4 board that does the USB host hub stuff, and then also like has logic connections to common developer form factors, so that I can take any plug into any Arduino shaped thing and have this like hardware in the loop testing work on that pinout. Yeah, I think the hubs, it's the like root hub code's job to like go through enumeration, and part of that's like talking to the hub and figuring out like where it is in the tree of stuff. Okay. So if you want to follow along, I'm missing the top piece. So the third piece that I have not pushed yet is that pyserial to PyUSB adapter. I was tweaking that a little bit, but that's the third repo. And then right now you can't, so the reason to target pyserial is that pyserial is used by the IDF tools and a lot of other stuff for serial stuff. Pyserial is like the de facto Python interface to serial boards. So ideally you'd be able to just say like, hey, do PyUSB at this address, at this like IP address and this like location on that IP address. And then you'd be able to do whatever you want with pyserial down to that device. The way that you can extend pyserial now is a little funky. You have to be imported in the same program, even though there's like a way to register with pyserial. It just doesn't happen. Getting it to happen is a little tricky. So I had to like modify ESP tool in order to test with it. But that's not too bad, and I'm kind of exploring options of, there's this Python library called Pluggy, where what you do is you can get metadata about all the installed packages from something. So you could say like, hey, I'm pyserial, like tell me all the other packages that claim that they're extensions or plugins for me, and then load those two in this like plugin way. Okay, so Taya said, what's the drawback of the octoprobe tentacle versus your Dream P4 version? Here's the octoprobe. It was, I don't know exactly why, but it was like kind of more expensive than I would like. I mean, I only bought 5, but one, it is designed with like USB in mind, so like I could hang one of these off one of my bridges, which I definitely kind of was thinking it at the time. But the other is, and it's got 2 separate RP2350s, I think, or maybe they're 2040s. I think they're 2040s. One's for like being a like twin pin twiddler, and then the other one's being like the SWD probe. But also, I'm really lazy, and I'm not that interested in like soldering down to this and wiring to it. So that's part of it, is like what I'm picturing now in my brain is like I have this standard P4 board that exports all its GPIO and has 3 USBs, 1 for itself, 2 for host, and a hub chip in there. So the 2, because I think you want 2 host ports, 1 for your serial link to the device and 1 for loading, and maybe more. That's the nice thing about USB. And then you want just like a bunch of GPIO pins out, and then you want an adapter to a particular form factor. Because like most of what I'm doing is like testing certain dev kits, right? So I could have an adapter between this board with a lot of pins and a QT Py, and this board with a lot of pins and a feather, and whatever form factor I'm wanting to test. Arduino Uno is like still quite common on dev boards, so like being able to just plug into that and like at least exercise everything in that space is really interesting to me. So yeah, lots of dev boards have 2. So 2 USBs. So it's 2:30. I do want to get out of here at 3 because I want to watch the moon return stuff. And yeah, so let's just do mailbag. Let's do mailbag. So I've got this box here that I just got today that I was excited about. It's a Digikey box. If you know me, they did not pay me to say this, although I think Adafruit does get paid by Digikey to do some other videos. But I often go on Digikey and just grab dev kits, especially inexpensive ones. I just submitted a feedback to them that I'd love it if they could sort the new. They have a new products designation, but they don't sort it by like the newest of new. Like they don't have a date associated with it. So like sometimes I'll go back to look at it again and I see a bunch of these things that I've already seen. So I said like, hey, it would be great if you could sort or filter by like newest after this date sort of stuff. Okay, so I've got my more dev kits. I've got so many dev kits. It is ridiculous. Let's see what we got here. I got the the cardboard cushioning, or the paper cushioning. First thing here is RPi Pico 2040 W5500. So the other thing I was working on is Ethernet support, which I still haven't tested. But this is a board. It's double wrapped in ESD. So this is like it's like a pico, but it's got this giant Ethernet thing hanging off of it, and it is supported by Zephyr, so I want to make a Zephyr board def with Ethernet support for this. And what is the other thing I'm thinking of? Hey, they have a run button too. Nice. One of these is a POE version, and I don't think this is it. So that's one, and I've got, oh yeah, I've got the other one here. This other one comes in a box, so maybe that is, I don't know which one's the POE version. Maybe I didn't get the POE version. This is similar. I thought one was POE, one was not. This one comes in a box. I need to get back to Ethernet, and Ethernet's one of those things that's like less easy to test in an isolated way. So I have been thinking about that a little bit. Like, yeah, I'm gonna get broad coverage that I need for the IDF stuff, but this looks pretty similar. I don't know which one is. So, sorry, I'm looking at it too. So that's the other WISNet one. And what else do I have? So I was going, this took a little while. It took like 4 days to ship, and then it took a few days to get here. So remembering exactly why I picked all these is a little tricky. So this says MCX A366. And I think the reason I was interested in this one is because it has LCD support, if I remember right, which I kind of realized that like maybe that wasn't the, having native LCD support on an MCU is not necessarily that interesting, because there are I2C chips that can do it. But yeah, that's what this one does. It's supported by Zephyr, so again, like, I justify a lot of these by just saying like, oh, they're Zephyr supported. Sorry, I'm taking out all the packaging. I don't need all the packaging. I think somebody pointed me to the MCX-A's because they're like 5-volt tolerant, or maybe even capable. MCXs are all the like newest NXPs. And you can see here it's got the segment LCD there, which I thought would be kind of neat to add an API for that to CircuitPython. Isolated NetBit has made me realize there's real advantages to single board computers for the hardware in the loop stuff. Create a Wi-Fi AP, has RJ45 or USB or not, tcpdump, min in the middle, all the things. Yes, so I was actually doing that earlier in the week. I was actually TCP dumping. So the cool thing is like you can use, I could use my Linux computer as the client, the USBIP client with the ESP server, or I could do the reverse of use my Python code as the client to a USBIP server that I am that my own computer is hosting, and you can TCP dump either of those. I also added the ability, which maybe I don't need to TCP dump it, but I added the ability to write pcap ng logs of just like the herbs. So like the USBIP works at the like quite low level of USB, and so I also added the ability for like the bridge, the like Python code to the bridge to just dump it out as well. Okay, so let me take this one out of the bag. MCX 444, 3 4s. Again, this is like in that newer family. It is beefier than the A series, I think. And if I remember right, this has Ethernet. So I've been thinking about like whether the P4 is the board to go with or the chip to go with. Partly because of not wanting, partly because of you can't do the standard, or you can't do fast assembly on JLC with the P4. You can only do like standard assembly. because the like pin pitch is too close. I've gotten more USB cables with these. And I'll just show this board. I think, well, it's pretty small. Maybe it doesn't have. Oh, so this is another LCD. This is another LCD one. So just take this as an example of like something it would be great to harness up. So like it's got two USBs, one's to like an onboard debugger. And then although this looks funny, like the pin out here, it actually is also an Arduino. Like there's an Arduino Uno footprint inside of this. So you don't get all the pins, but you at least get that. So that's another example of like, oh, I buy this, I slap like my harness onto it and then load CircuitPython and then be able to test like all of the functionality of it, or a lot of the functionality of it as a baseline automatically. So I think that would be really cool, which is part of the reason how I justify all of this. Like these are like, my impulse buy amount is like $20 or $30. However, this one I knew I wanted, and it was more like, I think it's like $50. So this is the other reason it was in stock. So I was like, oh, I got to grab this. So this is very similar, and it better be what I actually want. The box doesn't say it, so I will have to check. It is an ESP32P4 function EV board. Yeah, I don't think the MCX444 didn't have Ethernet. I was looking at the LCD stuff, so I think that's it. But on the back, it does tell me more information. This is why I bought this. It is revision 3.1 of the ESP32P4. So they did a big revision. I didn't know there was a free shipping limit for a Digikey. I don't think I get that. I pay like the $7 shipping. So I have a P4 sitting next to me, but they did a big chip revision of the P4. This is the one next to me is 1 point something, 1.3. And then they like did an actual like full chip revision, not just, sometimes you can do like partial revisions by doing just the metal layer. But then if you have to do the masks themselves, like all the way down into the silicon, that's what this is. So version 3 of the P4, and there's actually multiple versions of it. This is apparently 3.1. And they do warn you that it's an engineering sample. But because like the P4 is probably the next chip we're going to get into, it's just like very nice to have different revisions of silicon for them. And then I'm doing a lot with it right now with all this test harness stuff. So it just gives me another board to test with as well. IDF6 actually defaults to version 3 of the P4, which is interesting. Even though like you can buy other third-party boards with an ESP32P4 as well. So yeah, that's my mailbag. That's the last thing I got. This one is expensive. I was thinking about this. I was like, maybe I should just base it off this board because it's got a lot of what I want. But the problem is that it comes with a display, I think, which makes it way more expensive than if I just got the board. So like, here's the board. It's got a nice label right on the Ethernet jack of what chip revision it is, which is great. I'm sure the board itself is this, I think it's almost the same. Yeah, it says, my other one says version 1.5.2, and the new one says 1.6. So they're pretty close. And then it comes with a camera and some like adapters for the LCD. And this is like, yeah, I wish I could get the P4 in a cheaper form factor because it also comes with a screen. Now it's possible the screen is actually different as well. So it comes with like a DSI screen. There you can see my light. So that's why this is like a $50-ish dev kit. And this is version 1.2 and 1.3, the HMI subboard. So I was using that for the DSI testing, but I don't really need it now. So that's my mailbag. We've got 20 minutes. Any questions? Any topics you'd like me to go towards? I know the other way I could go if I want to keep talking. I don't see anything specific. So maybe the other thing we should talk about is I spent some time last week and this week doing OpenClaw. So if I just show you, so this is my Telegram, and we could say, oh, you can't see it. Desktop. So here's Telegram. Here's my bot that talks to my claw. And I could say new. And I don't know if it's up. I have a lot of trouble keeping my OpenClaw running. So if you don't know, OpenClaw is this project that got really popular, I don't know, like a month ago, where you give it access to everything, and then it's like your personal assistant. And there's like people that have been buying Mac Minis, and I actually this is running on a Mac Mini that I happened to buy like last summer. Oh. Say hello to the live stream. I don't know what it's going to do. So this is me talking over Telegram to my OpenClaw. So it said, hey, live stream, Newtbot here. Scott's CircuitPython coding companion. We get into bugs, fixes, and the occasional rabbit hole. Should be fun. So this is using, so OpenClaw is this like integrate everything into an LLM loop. And there's some components to it which is like, hey, like once in a while, like wake up and run this thing. Like I was trying to get it to do issue triage. So like, hey, like at 7 a.m., like try to get all the new GitHub issues. And so Newtbot hasn't really read my bio. OpenClaw does have a very, well, it was pretty brief for me onboarding, where you say like, who am I? And it asks like, who am I and who are you? And it says like, and like, what do you want to do? So like, that's where it's getting these, this CircuitPython stuff. So it, like the Newtbot thing is that I called it Newtbot. It knows that I'm Scott and that I wanted to get on CircuitPython. So that's all stuff that like kind of got baked in as I onboarded it. It's been kind of a pain. It hasn't been working that well, and it certainly hasn't done the issue stuff. But one thing that it's actually been kind of helpful for is I set it up isolated. So I erased my Mac Mini. I made a new Apple account for it. I made an email for it. It has access to that email, although I'm not talking to it that way. It has its own GitHub account. So like the only credentials of mine that are on there are like my Anthropic ones, so that it could like call to LLMs. So it hasn't been that useful for actual like CircuitPython stuff. But what it has been more useful is actually just setting other stuff up on this Mac Mini. So the thing that I thought could also be interesting to look at is that computer's name is Lyft. And it's running llama.cpp. So this is a way for me to access different local models that I can run on my 16 gig Mac Mini. And I have a few set up. The ones that I was most interested in, we were talking about this week, is the two Gemma 4s. They're small enough to fit on phones. Does my OpenClaw pay taxes? No, but I do. I just finished my taxes. I was tempted to use Claude to help me fill out my taxes because I had to like copy over a bunch of like capital gains transactions, but I did not. But it is awfully tempting anytime I hit something tedious. Does the Mini have much of a GPU? It's an M4 base 1. I don't remember. I bought it off Amazon like when I was on paternity leave. So like June or July of last year. And the reason I actually bought it was I was off on paternity leave, and I wanted to explore this project for mapping, which I don't know if I've talked about, but like I have a history of working on maps, and I had this idea for maps that I really wanted to try. And actually Claude Code at that time was what I used to generate that code. It's called Atlas. Atlas app, and I like did it for iOS, and I needed the Mac Mini to do that because at the time I was using iPhone, and I had just gotten a new car that had like CarPlay, and I wanted to have integration with that, but like you need to get permission from Apple to even have a development app show up in your car, and I still haven't gotten that, so I actually switched to Android, and then like it became less useful. But now I have it running these models, so. I've been really curious about how good Gemma 4B, the E2B is going to be smaller than the 4B, but I think we could just switch to it, and then it will load up the different one. And it says model loaded, and as I did this earlier, so I know that it's going to be pretty interesting. Write a basic code.py does an LED blink in CircuitPython. So what I've been thinking is, so Phil has been thinking about this too, of like generating CircuitPython code using an LLM, a local LLM, and I was like, look at these Gemma 4 models that just came out. Like Google has a demo app that you can get on iOS and Android to try using these. I'm sorry, I don't know how to actually make it better or bigger. So this is a local model. It is not referencing anything besides what's in the model. Tyeth asks, does it have MCP tools, shell access on the Lift machine? Can it print the free memory after loading the model and running a prompt? I don't think this llama.cpp does. But if we talk to, if we loaded that, how much memory? So I'm talking to the Claude now. So this is like running Claude Sonnet, I think, is being used by llama.cpp now. We'll ask the Claude that's running on the same computer, and we'll go back, and this window is really tiny, so sorry about that. It's doing exclamation of the code, which looks kind of like garbage. But I think it actually did do it. So it says, save the following code as your code.py. It imports time, board, and digital I/O. So both board and digital I/O are like CircuitPython things. And it doesn't have any, it's not referencing anything. As far as I know, there's no skills. It didn't do any searching. This is just from the weights of this like model that I'm running on my 16 gig Mac Mini. So it successfully like said, here's the pin, do digital in out, and then in the while loop it does true for on, sleep, false for off, and that works. So that's pretty awesome. Now I'm imagining a world where you have like a mobile app where you say, hey model, write me this thing, and here's a tool for loading it on the device, and it says, okay, load this on the device. Instead of telling me to do it, it would actually just do it itself, and then we could get the output of it and feed it back, right? The follow-up that I was trying with earlier is now, let's first just tell it to blink faster. I don't know why it doesn't submit. Mark says, I haven't gotten into local LLMs for coding yet. Curious how they compare to Claude Code, though a lot of it is the power of the prompts from what I've read. So yeah, we were just talking about this in our Slack channel too, of like how good this would be, these local models would be if it was harnessed. So like being able to like reference things, like reference what the API docs are and things like that. so I said, okay, fast blink now, and it said like, oh, we're pausing for 0.5 seconds. Let's change that to 0.1. And now it's done that. So it passed that test. And the other thing I was trying was, okay, now do it with a NeoPixel. So this is like I said, this is a local model. It's only got 32K context window. I haven't seen it compact yet. So it's thinking, we can see its thinking trace here, understand the goal, identify the requirements. So I think there is like a system prompt that llama.cpp is probably injecting into this as well. But now we can see it coming back, and now it's saying like, oh, like now it also has Adafruit NeoPixel, picks the pin, the number of pixels, and the delay. This looks correct to me, although things that look correct aren't necessarily right. But nothing obvious. And then the while loop, where it sets it to red, it shows it, it sleeps, and then sets it to black, shows it, and sleeps. It's interesting that it doesn't use auto write to do it. Mark says, setting up a whole system to use the model tools and agents is a lot more work. Was trying to do a RAG search using just local models with so-so success. Yeah, I didn't try the search stuff. I'm curious to try this. I was trying this actually within the Py coding agent, which I would like to use more of, but it now costs tokens rather than a subscription to Claude. So, but yeah, it nailed it. So let's actually just do a new chat. And let's switch to the smaller model. And I already did this earlier, but it is interesting to compare the two. So the E2B, I think, actually takes less. And OK, so it says Llama server is using 34.6 of RAM right now. Let's see. Did it load up? Yeah, so can I go up, right? A basic code.py, blinks, and LED. So we'll see. Yeah, Tim points out that NeoPixel is one that doesn't have the Adafruit prefix. I think you're right. See, that's I think the value in those feedback loops, right? Is like, if it could auto load it onto a device, it would just know. It would be able to tell, hey, this one's definitely faster. Oh, it's got a try finally. Not so good. Oh, you know what? But I didn't say for CircuitPython. Okay, that's fine. So this is using RPy GPIO. It's interesting that it does like the setup, cleanup, blink phase. Oh, and it's catching a keyboard interrupt. All right, well, let's see how it does with, do it for CircuitPython instead. Does it mention bash? This is just how to run it here. So it says, so do Python 3 blink LED. And then it explains it. Do it inside, but don't explain. Okay. So this is like the first time I have really played with these local models, and I'm impressed. I'm quite impressed with these Gemma 4 models. And the OpenClaw was actually like really helpful to set that up. Like, it's got this own sandboxed environment. I've got like on the router, like I can talk to this Lyft box, but Lyft can't initiate connections. Like the router does it that, like replies are okay. And look at that. It didn't tell me anything. It just printed the code out. and that's the E2B model. So let's say now do it with a. It's funny that Tim had to point out to me that like the NeoPixel import's wrong, because I didn't notice. This is oh look, it got it right. This one got it right. E2B got it right. It didn't put the Adafruit prefix. And that looks okay. LED pin, auto write, false. It's interesting it does auto write false. So that must be like the way most people do it. Oh, and it's doing each individual pixel. It's not calling fill. Interesting. Oh, and weird, it put it in a function. No, I don't like that for simple examples. Don't put the blink in a function. I wonder when I'm gonna run, or I'm gonna hit a compaction. I'm only at 5% context now. So this is really fun. I was already like briefly looked at like, okay, how much would it cost to try something else? There's a couple people at Adafruit that got the framework high memory ones, which when they came out, I was like, ugh, why are they doing this? And I'm like, I kind of want one. They're like $2,000, but they are kind of interesting. But actually, these Gemma models are interesting from the perspective that they're actually like runnable. Like this, I think we could get this output in an Android app or an iOS app, and that would be amazing. That would be amazing. But yeah, I'd love to try that on mobile devices, because like I've always had this fantasy of doing CircuitPython code from a mobile phone, and typing on a phone and inputting stuff just is terrible. And so like something like this solves that problem, and that's just amazing. Taya says, now you're like 2K for that much RAM. Temptation. Yeah, and they also just announced that they have some next gen announcement in the next couple of weeks. Like 11 days, like the 21st, I think it is. I'm a big fan of framework because I really like their laptops. Like I switched from the 13 to the 16, and I could bring my webcam, like the upgraded webcam, with me. So how did the knowledge get into the model? Where was the training targeted? This is the generalist Gemma 4 model, and I assume that's trained on just, you know, all of the open source code that we have. So I've seen people describe it as like it's built into the weights of the model. I haven't done any post-processing or anything on top of it. I've just taken Gemma 4. I've had it take Gemma 4 and do that. Mark says, I wonder what it would cost to take a coding LLM and do a training modification feeding it a ton of CircuitPython code. I mean, I think because it's open source, it kind of already had it, right? Like, and I don't want to get in the business of fine-tuning models. Like, I'm much more interested in and this is where I'm living with most of my work. It's like I'm interested in the loop, the feedback loop feedback loops that you can build, right? So like, and so it's like skills that you're giving access to the agent for. So give it ways to look things up, and then like also to initiate trying it all directly itself. So yeah, that's where I'm going with it. I think it's really interesting. And I was very impressed with the Gemma 4 models. I was like, wow, it's doing that even without any references. So like on my phone, I was like, oh, what is CircuitPython? And it had like some skill that's like Wikipedia. And so it like went and fetched from Wikipedia like what CircuitPython was. I was like, oh, that's great. It's kind of cheating. But this, as far as I know, like it didn't do any, like it had some thinking. But as far as I know, this is just all that's in the weights. And if I'm wrong, let me know. But yeah, that's been cool. And I wouldn't have tried this if I didn't have OpenClaw on this thing. So it's kind of been useful for that of like, I also said like, oh, what are other similar models that we can try? And so it installed those as well. Mark says, one failing I've seen to a degree in Claude still is when you ask it to use a fast-changing library. It doesn't always look up the latest. I am watching the clock. I see it's 3 o'clock. I'll wrap up right now. Yes, that I ran into that with Claude 2, Mark, where like I had it generate some CircuitPython code and it did the translations in like the old way that we had done it. So I think it is really important. Like Gemma 4 was just released, so it's like right now it's up to date. But I think having material like words that or code that like it can decide to reference is really powerful. And that's how you kind of like mitigate the fact that like the weights are a little stale. As you say, like, oh, like if you want to look up the latest API, you can look here or just search somewhere. Like a lot of this USBIP stuff this week was like, and I have the Linux kernel, it's checked out in repos/Linux. Like if you need to reference the way Linux does it, look there. Like I don't want to have to give you permissions to GitHub and GitHub raw user and all that stuff. Like I've cloned it, it's just there, you should look at that. All right, thank you all for that adventure. So this has been another deep dive with Scott. I think I'm around next week too, so I'll see you in a week. Hopefully I'll have like end-to-end testing going. That will be amazing. And maybe I can make some more progress on the IDF6 stuff. It was kind of waiting anyway because we decided to like not commit it until after we do 10.2. So I had a little time there. If you want to support me, you can go to adafruit.com, purchase hardware there. They pay me to do the streams and work on CircuitPython and indirectly buy all these dev boards. Thanks in advance to DCD for timecodes. Thanks to Tim for doing deep dives on Tuesdays and filling in for me when I'm unable to do it on this Friday spot. With that, thank you all. Have a great weekend. I'll pull up the window so we can see a little gray day here in Seattle, although it was kind of going to be warm, so I have shorts on, which worked out. And I'll see you all on the NASA stream probably. I'm going to switch over to watching 4 astronauts re-enter the Earth's atmosphere, which happens in the next couple hours, I think. So best wishes to them, and I will see you all next week.